right, next we have Tim Hyland, an environmental scientist with the Santa Cruz District of California State Parks. He'll be talking to us about the impacts of exotic species on the San Lorenzo River watershed ecosystem. Tim first became interested in native plants while gardening in his parents' yard in San Jose. He was able to turn that passion into a job working at a native plant nursery in the Santa Cruz Mountains and later as a natural resources manager for the California State Parks in the Santa Cruz District. In that role, he has been working to protect the amazing diversity found here by controlling invasive exotic species for the last 25 years. All right, thank you.
Well, thanks everybody for coming. So I'm going to talk to you about a little bit of the work that we've done in California State Parks over the last quarter century, but kind of more generally just about why should you care about plants, right? Why should you care about exotic plants, invasive plants? I think all of you probably recognize these plants. We've got our iconic redwoods and unfortunately nearly as iconic English ivy. And so anybody want to give me their standard definition for what a weed is? Anything you don't like. Thank you. Yeah, and mostly, you know, a plant that you don't like, a plant that people say a plant out of place. For California State Parks, given that our mission is to preserve, in part, to preserve the extraordinary biological diversity of the state of California, then that is a plant that impacts that diversity, right? So, but you know, if you ask most people, what is a weed? They say that's a weed, right? We have some native thistles. This isn't one of them. So actually, we have some lovely thistles that encourage the biodiversity of California, but this is bull thistle. Everybody pretty much knows that one. You know, that and a dandelion, if you show those, or if you say weed, that's what springs to mind. No. There? No. Why is that even in there? It makes sense in another presentation. So how about this? Is this a weed? Yes. But can you buy it in the nursery?
Yes.
Why? It's pretty. Exactly, right? But why don't we want it? This is really challenging. How about this? Is this a weed?
Yes.
Again, you can buy it in the nursery, you can plant it, it's widely planted. It's pretty. Why is it a weed? Right, let's try one more. Another weed? We all agree that it's a weed? Yeah. No, we go back and forth, right? So this is Himalayan blackberry, which does tend to create barriers to wildlife along the edges of riparian areas, along stream sides. But it has these wonderful, tasty berries. I love to pick them. I love to eat them. I like to make jam out of them. But it is a weed. It is impacting the diversity of our state and our state parks and our watershed. How about this? Yeah, I think everybody in the San Lorenzo Valley recognizes French broom as a weed, right? But you know, it takes over. That's often when people talk about weeds, they say.
Just tell me next slide. I'm not going to do it.
Yeah, I noticed. So how did these weeds invade? Right? We have a whole landscape full of native plants that are adapted to this climate that have been here for tens of thousands of years. And you know, you would think that they would be best able to kind of occupy the space and to compete in this space, right? So why is it that we're getting all these weeds? Well, the vast majority of the weeds that that show up are from this Mediterranean climate zone, right? So we're in a Mediterranean climate. Anybody want to tell me what defines a Mediterranean climate? Cool, wet winters, warm, dry summers, right? So that's what we have. So this is, there are only a few places with that climate, notably the Mediterranean, but us too. And they are actually areas of very high plant diversity. So these are some of the most diverse places on the planet for plant diversity. But, you know, all of these plants are evolved to the climate. Let's try the next one. But they evolved in isolation. Actually, let's go back. So they all evolved in isolation. Well, maybe this will work too. I won't have to wave my hands. Nope. You know, there are things that evolved here and then evolved here, but they're all separate, right? They all had a long time to kind of figure things out on their own. Now let's try this next one. So recently, we've kind of taken all those barriers away, right? We've gone ahead and we have tied the world together. You know, all of those barriers that kept those places separate aren't there anymore. And when you take, I mean, you just think about sports competition, right? Actually, today are the Olympic trials for the marathon. And all of the very fastest runners in North America are going to compete against each other, right? And three of them are going to get on the Olympic team. So now we've got the best of North America. Are they going to win the Olympic marathon?
No.
No. No. I suppose they could, but probably, God, I hate to doubt them, but they would try. But probably not, right? Because there are other faster runners in the world. And so even when as you connect the world, you get fewer and fewer species that are able to compete. They all compete, but there are fewer and fewer winners, right? You just have fewer and fewer winners. So let's try the next slide. So, you know, how do they do this? One of the things, unlike the runners and just the mathematics of things, is that these plants evolved in places with, you know, in a community. And what eats plants? Mostly insects, mostly bugs. Bugs is better than insects because it includes, you know, snails, it includes mollusks and all sorts of stuff. And so plants are in a constant arms race with insects. Because if I'm a plant and you're something that wants to eat me, I can't go anywhere. I can't run away. If I'm an animal, I get the heck out of there. So what can I do to make sure I don't get eaten? I could be prickly. That would be good, but insects are small enough they can get around prickles. What else could I do? Poison. Taste bad. So plants are the most amazing chemists, and they're in a constant arms race with their predators, with herbivores that eat them. And so over all that time where these plants were evolving, they evolved defenses against the insects that were there, but the insects are evolving rapidly to keep up, right? So when these plants leave the area where they evolved, they can come here and the insects haven't caught up yet, right? So they're not having to actually produce all those defenses. It costs something. It costs the plant energy to create poisons, to create toxins, that sort of thing. So they have all of that energy then to spend on reproduction. So, big deal. So we have ivy instead of redwood sorrel. Who cares? It's just plants. Pink is pretty. French broom flowers a lot. You know, that forget-me-not is lovely blue along the edges of the trails, right? So what? Well, if you don't care about plants, which most people don't, let's face it, you probably care about animals. So would you be excited to see this when you were, out on a walk, say? Or this, depending if your garden is well fenced. This would be kind of cool to see. I like seeing brush rabbits. Or how about a berried thrush? They're pretty cool. Or how about a Swainson's thrush? They're beautiful. They make beautiful, beautiful calls. How about a ringtail cat? Anybody ever seen a ringtail cat? Yeah, they're here. They're related to raccoons, but they don't get in as much mischief. They used to call them miners' cats because they'd hang out around the logging camps and that sort of thing. Or how about this? It's always fun to see a red-tailed hawk, right? So do any of these animals make their own food? No, they don't. Do any animals make their own food? What is the only life form on the planet that makes its own food? Plants. So if there were no animals, would there still be plants? If there were no plants, no animals, right? So even if you don't care about, another fun thing, as long as you've got your chickens well fed. And so plants form the basis for the food web, trophic pyramid, call it what you want. And mostly it's insects and other bugs that are eating them. And then those are prey to larger animals, snakes, birds, and on up the chain. So let's see the next one. Right? So, plants are the base of this pyramid. And without them, you have nobody else. And let's see, what just a second. I'm going to look here and see what I have next before I tell you to change it. Right, okay. Let's see the next one. These are invasive plants. Invasive plants are empty calories in the ecosystem, right? They're there, they're taking up space, they're photosynthesizing, they're growing, they're making seeds. And while you can eat them if you're an animal, they are not nearly as nutritious, advantageous to animals and their reproduction. They didn't evolve with them, they didn't adapt with them. So the more space that is taken up by invasive plants, exotic plants, the less real food, productive landscape you have to support all of the rest of the ecosystem. So even though nobody cares about plants, it's a good idea to pay attention to these impacts. These are the impacts that, that first slide I had of the English ivy are having on that system. They are undermining the base of that food web, of that pyramid. So the good news is, next slide, the that you can do something about it. You know, some of those, English ivy grows remarkably slowly. All the researchers who are researching English ivy are always just super frustrated with how slow it grows, because it takes so long to get up and flower. So that's a plant that you can just go out and you can hand pull, and you can make a difference. You can make a space for native plants in that area. So by not planting exotic plants, by removing them where you have them on your lands, you can make space for native plants that the native animals have evolved to eat, and you can support all of those systems as we go up the chain. That's it. Thanks.